This video is on oblique impact. We recognize that we have impact when we have very special situation. We have very short period of time in terms of action between objects, and they generate large impulsive forces. The period of time is so short that we can ignore all external forces. All external forces, friction, for example, or some external force which is acting on the system, like input, some kind of input. So we only focus on what is happening between two bodies. In central impact, we have velocities which are on the same line. Moreover, those velocities are on the same line as both centers of gravity. I will draw it over here. And we refer to this special line as line of impact. Basically, by definition, line of impact is line which is going through centers of gravity. So here we have this situation, and velocities are on this exact line, and all action is happening along the line of impact. Central impact is quite simple in terms of analysis. We have forces which are acting between two bodies, forces of deformation, forces of restitution, and anyway, all forces which are happening are along the line of impact. And for central impact, we apply conservation of linear momentum for two bodies. So MAVA1 plus MBVB1 equal to MAVA2 plus MBVB2. So that's what we apply in this direction. Also, we use coefficient of restitution. So we have velocities of separation 2 minus VB2 divided by VB1 minus VA1 in this order. Velocities of separation divided by velocities of approach. Both these equations are applied along this line. That's what we do in central impact. Now we are going to look at oblique impact. And oblique impact will have also two axes. Line of impact will go through the centers of gravity. That's where line of impact is. And velocities will be at some angle. In respect to line of impact, not as it was before, but at some angle. Before it was all along line of impact. Now we can have one or both not on the line of impact. It will be more complicated, and we will have to analyze not only in this direction, but in this direction as well. We use two axes to analyze oblique impact. Line of impact, no worries, going through the centers of gravities, and plane of contact. And we will call them XY axis just to make it convenient for us. But we remember that we do not have actually an option to choose it somewhere. We must put X axis through the centers of gravity, and Y, which is plane of contact, will be perpendicular to X axis. What is happening here? Obviously, we have some velocities and we have some forces of action and reaction. So we have velocities of approach, no worries. Let's put it in this general form like this. Both are at some angle. And we have velocities of separation. Also at some angle. So obviously, out of all this, we want to figure out something. We want to figure out, for example, velocities of approach if we know velocities of separation, or it might be other way around. We know velocities of approach and we want to find velocities of separation. In both cases, we will have four unknowns. Those four unknowns in this case will be, for example, components of velocities, x and y component. Alternatively, it could be, for example, magnitude of velocity and angle, corresponding angle. For example, let's take this one. How we can express this velocity? This velocity can be expressed vp2 as a vector, can be equal to v lots of subscripts here vb2x as a vector plus vb2y as a vector. So two components, two vector components in x direction and in y direction. Alternatively, we can express this particular velocity vb2 can be expressed as magnitude of vb2. So magnitude will give us magnitude of this vector. Let's put it like this. And angle, for example, this one, so the one which belongs to vb2, phi2, will give us direction of this vector. In both cases, for each velocity, for each unknown velocity, we will have two unknowns, which means that for the total setup, normally we have four unknowns. In this case, we are going to analyze in x direction and in y direction. Let's go to the next slide and let's agree on very special thing. We looked at velocities, no worries, but there are forces as well. And doesn't matter that now velocities are at angles, velocities are at some angles, forces will be still only on the line of impact. There will be some forces, deformation and restitution forces, which will be acting between what and what? Between centers of gravity. So there will be all action will be happening along the line of impact, and there will be absolutely no forces in this direction, so no forces in y direction. Let me write it here. So no forces along y. You see, forces will be only along the line of impact. Based on this, we can separate our analysis in x and y direction. So here we have x axis. So in this part of the screen, we have analysis along the x-axis. Along the x-axis, we are going to do absolutely the same stuff as we did for central impact. So we are going to analyze A and B together. And we are going to write conservation of linear momentum in the same manner as before. But it will be in terms of components of velocities in x direction. So it will be MAVA1x plus MBVB1x equal to the sum of momentums of separation also in terms of components of those velocities and coefficient of restitution. Now let's look what is going in y direction. So here I have stuff for y direction. The good news is that there are absolutely no forces here. What does it mean for us? No forces whatsoever in y direction. No forces means no acceleration. No acceleration means no change in velocity. So in y direction, velocities will not change. So whatever we have in terms of component of velocity in y direction will stay the same. So let's, for example, take this bit. So here we have VA1y. Where is it? Here we go. This is the one. And here we have VA2y. And because we know that there are no forces, no acceleration, no change in velocity, we can say what? That this one will be equal to this one. This is from conceptual point of view, and as a way to predict a possible result, mathematically we can write it like this. We can say that in y direction, because there are no forces, we can analyze particles separately, and we can write that, and we can conclude momentum will be conserved for each particle. So I can write m a v a 1 y equal to m a v a 2 y. So we have conservation of momentum for each particle separately. Obviously, you see that mass is not important here, and we simply have result that component of velocity in y direction do not change. It do not change for A, and it do not change for B.